Hello, and welcome to our first inter-university hackathon, UmojaHack. My name is Jonathan, and on behalf of Zindi, I'll be taking you through a little bit of a technical introduction to the challenges you're going to be facing today. So we'll start by looking at Zindi as a platform, and then we'll go through an example of how you can get the data that you'll be working with, how to make submissions, and so on. And we'll run through each of the three main challenges that you'll be facing, just to give a bit of a rundown of what exactly you'll be working on, the data that you'll have to work with, and how you'll be making your submissions. Let's get started. So this is the Zindi Hackathons tab. If you haven't already signed up or signed in, you can do so here. And so when you click on the hackathons, you'll see we have UmojaHack running, and these three challenges are open. So heading to one single challenge, this is what a competitions page typically looks like, and same with the hackathons. So you have a couple of different tabs here with information about how it's going to run, the timeline, the prizes, how we'll be evaluating results, etc. So make sure to go through all of those to make sure that you're not missing anything crucial. Under data here, you'll see the data that you'll be working with, but first you have to join the hackathon. Let's do that now. I just need to enter my super secret code, which we'll be sharing with you at the end of this presentation. Okay, so now we've entered that, we've officially joined the hackathon. We can download the data and start exploring. So what's this competition about? Well, the South African Environmental Observation Network, SAEON, don't judge me on how I say that, they might pronounce it differently, they dredge up all manner of weird and wonderful creatures from the sea floor. They go out in a big research vessel and they pull up with these nets. And so they get hundreds or thousands of specimens. So they take a photograph of each one, and then someone has to manually go through and identify what species are present in the image, and optionally like update their field guides, record it if it's an interesting species, keep track of the ecosystem health by monitoring what they find. So the identification is a very manual process. And so our goal today is to help automate that. So you'll be given a lot of images of sea creatures. I think we have 137 different species. So you get examples of each species, and the goal is to build a machine learning classifier that can take in an image and predict what species that image shows. So what makes this competition interesting? Like I said, there's 137 different species. There's not that many images for some of the species, so you have to work with very sparse training data. It's a good opportunity to look at things like transfer learning and data augmentation to help build a better model. And the best part of this competition, in my opinion, is these amazing creatures. It's much more interesting than looking at dogs and cats and cars like many machine learning vision competitions do. Speaking of those amazing creatures, why don't we take a look at some? So this is what the data looks like when you first download it. You get a pair of zip files. Extracting those, we see that the train folder has a separate subfolder for each species. So each species has 10 or more images in its own little folder. And so the way that you can tell which species and images is to look at the folder that it's contained within. It's a fairly common way to share data during machine learning image classification tasks. On the other hand, let's go and look at the test folder. You can see here, there's just a whole bunch of images with no subfolders. This is obviously because we don't want you to know what species these are. Your goal is to figure that out with machine learning. So come submission time, you're going to make a prediction for each of these images in terms of how likely you think it is that this image is a special type of starfish or a shrimp, etc. Those are not the actual labels, by the way. I think they have scientific names, so you'll have to get a bit more technical than that. Let's look through some of these images. Like I said, the funnest thing with this competition is just going to be looking at the pictures. There are some wacky creatures in this world. Okay, so how exactly do you make a submission? We've got our predictions for each of these images, and you've used some different library. Maybe you're a PyTorch fan or FastAI. Maybe you've put them all through TensorFlow, some sort of pre-trained ImageNet model. You've got your predictions. How do you make a submission? So this is the sample submission file provided by Zindi along with the training and test data. And what this shows you is the format that's needed to get a score in the competition to make a submission. So you can see here the column on the left has the image name. So that's the image file that you're considering. And then all the subsequent columns correspond to one of the potential labels. So this is a single label multi-class classification problem. So your goal is to assign essentially a probability or a confidence score to each category for each image. So for example, if you were convinced that the first image here is of a polychaete worm, you would have, say, 0.9 in that column and very low numbers in all the others, because you're relatively confident that it's this worm, and you're relatively confident that it's not any of the other categories. So that's what your submission looks like. Once you have a submission, you head over to the Zindi site, click on Submit, and you can upload and get a score. Now, there's a couple of things that quite often go wrong here. Make sure that you have all the right columns and the column headings. It's important to follow the sample submission. Check that you have a prediction for every image. Again, look at the sample submission to see what rows they're expecting. The order isn't super important so long as they're all there, but the order of the columns is very important. If you get that wrong, you might get a really terrible score and not know why. You might also get an error if, for example, you've left in an index column or you've named your column headings differently. So yeah, just try and follow the sample submission as closely as possible. Ideally, load that up, edit the actual data in that data frame without changing the shape or the columns or anything like that. Save it exactly as it was, except that you now have actual numbers instead of zeros in the sample submission. Cool, and then your score appears here on the leaderboard. Your goal is to get to the top. In this case, the metric is log loss, so lower score is better. You can try out all sorts of techniques for replicating the scoring process yourself without needing to upload to Zindi each time. This can also help you pick between different models locally, and help you refine your data augmentation strategies. So that's a very basic overview of how a competition will run on Zindi, this SAEON challenge. Next up, we'll take a slightly shorter look at each of the other two challenges, and then I'll go over some general tips, and we can move on to a brief time for any questions or clarifications. Okay, on to the second challenge, the Xente Purchase Prediction Challenge. The task here is a little bit different to the one we've just looked at. Instead of classifying images, you'll be trying to predict whether or not a given customer will make a given purchase on a particular day. So the training data that you provided is essentially a transaction history. So a series of individual transactions by many different accounts. You have the product ID, and in a separate file, you can find out which products fall into which categories. This is something like airtime or television subscriptions or banking services, etc. Yeah, so you have this transaction history, and you need to go from that transaction history to whether or not a given account is likely to make a given, or to purchase a given product on a given day. So it's quite a tricky mapping. There's some fairly sparse data to work with, but you can do things like grouping customers together, looking at similarities and purchasing trends, looking at how seasonal different purchases are. For example, like a subscription might be once monthly, whereas something like airtime might be daily or weekly, depending on the customer. So you're going to have to come up with some tricks for grouping customers together, for making those predictions, for figuring out how you threshold your probabilities, because the other interesting part of this competition is the evaluation metric. It is the F1 score. So you're not submitting probabilities, you're submitting ones or zeros. So you've got to kind of make your hard and fast predictions and try and optimize so that you can guess which products are most likely, put a 1, zeros everywhere else, and see if you can maximize your score and make it to the top of the leaderboard. So that's the challenge in a nutshell. There will be time for questions afterwards for all three of these challenges. So if something isn't making sense, don't worry. We'll try and explain that. Let's move on to challenge number 3. All right, so we're on to challenge number 3, Hotspots. So this is predicting fires in the DRC. And for this challenge, we actually have a starter notebook to get you going. So instead of just presenting the challenge, I'll run through the notebook highlighting important features. So let's get to that now. So this is the starter notebook. You'll see I'm running it in Google Colab. And I've already mounted my drive, and I can copy across the train, test, and sample submission files from Zindi into the Google Colab environment. So I don't have to actually download the data. I can just interact with it in the cloud with access to all sorts of common libraries and some decent computing resources. So this is a nice way to get around slow internet or slow computer at home. It all just happens on the cloud, provided you've got an internet connection. Okay, so these are some libraries I'll be using, and this is what the training data looks like as provided by Zindi. So you notice there's quite a few different columns, but the important one, that sort of target variable that we're interested in, is the burn area. So there's many different locations all over the DRC, and for each month, we have the burn area. This is the fraction of that region that has been affected by fire, it's been burnt, usually land clearing or forest fires, etc. So this is what we're going to be trying to predict. We have a bunch of input variables that are all derived from various open source data sets. So you can go and look at the data page to learn more about these different climate variables. And that is evapotranspiration and precipitation and temperature, minimum and maximum, humidity, vapor pressure, etc. We've also got some simple location-based ones. So you can see there's the latitude and longitude of the point, or the area rather. And we've got the elevation, you've got the land cover makeup. So again, you can go check out the details page to learn what the different land cover types are. So this first point, for example, 65% of the area is land cover type 4. And you can go and check what that is. I think there's urban areas or farmland or forest land or dry, arid, etc. So that's the different land covers. Finally, we've got population density, and then we've got another measure of precipitation over that month. So you can see the training data runs from the year 2000, and then the test data is very similar, except that the target variable, the burn area, is set to 0. That's what you'll be trying to predict. And it runs from 2014 up until 2017. So, okay, that's the challenge in a nutshell. The notebook takes you through some feature engineering, looking at which features are important. So you can see, for example, precipitation. When there's more precipitation, there's less burn area. That makes sense intuitively. You can investigate a couple of the other variables, look at the trends in more detail by doing some scatter plots. And there's lots to explore here and lots to deal with in this data. And you've got to get kind of creative as you add your features, but we start you off with a couple of simple ones. These are just some date-related features. So you can see there's a very strong monthly trend. It's generally the middle of the year when it's dry and land is being cleared for preparation for planting, which is supposed to come just before the rains in November, December. So you can see the sort of seasonal trend of this this phenomenon, these fires. And likewise, you can look at the longer term trends year on year. And then finally, I think this last illustration just looks at the rainfall and how the precipitation and the burn area, you can see there's a very strong inverse relationship there. So the notebook's got a couple more ideas for features. You can also, of course, just get creative with your own. Then the next step is we need some way of seeing how well we're doing. So you could, of course, just submit multiple times to Zindi. You're allowed to submit. I think there's some limit, but you can definitely try more than one submission. But that's very clunky, right? You make your predictions, you upload, you wait for your score, and then that's it. Whereas if you can test locally, you can run through lots of different parameters or lots of different models without worrying. It's very quick to try things. So it's highly recommended that you create your own validation set at home. And this is an example here. You can see everything after 2011 we keep for our validation set, and this will let us get a score locally and get a very good idea of how we'll do in the final leaderboard. So that's splitting our data into train and validation. And then we can just try a very simple model. So here, for those of you who are familiar with scikit-learn and doing sort of regression problems in general, this is very familiar syntax, but we're creating a ridge regression model. So this is one that has built-in cross-validation to pick the regularization parameter for you. It's a very nice, fairly simple linear model. So we're fitting it with our training data, we're making predictions on our validation data, and then we're showing you how to calculate the mean squared error, which is the metric that's going to be used for this challenge. So running that, we can see our mean squared error 0.05. So that's a sort of good baseline, right? That's without much trying, without many features engineered, that's the sort of score that you can expect. Now there's a little exercise here. You can try some different models, play with parameters, and when you're ready, you can start thinking about making a submission on Zindi itself. So this next section here takes you through that. We load the sample submission file provided by Zindi. It's probably got a different name if you download it directly. This is a file that I've been working with, but it has an ID column, which is just the area that you're looking at, and then the date and the prediction. So we need to fill in this prediction column with what we expect the value to be in terms of how much of that area is burnt in that month. And we have the test data, which is very much like the training data. It's just missing the burn area column. So we can provided we make sure that features match. So remember, we added these columns in the training data, so we'll do the same in the test data. We can then just use model.predict, since this is a nice easy regression problem. Model.predict to get our predictions. Add that into the prediction column of the sample submission, and you can see we now have values here where we had zeros before. And so as soon as you've done that, you're ready to save. And this starter submission file, which should appear here in the file browser, you can upload this to Zindi and get a score there. You should see that it correlates quite strongly with your local testing score. So that's it. That's the starter notebook for the Hotspots challenge. There's a few little tips here for bumping that score up. Of course, there's many other things that you could do yourselves, and we're really looking forward to what you come up with. Great. All right, I hope you found that informative. If everything goes well, I'll also be online just after this to answer any questions that you might have about any of the 3 competitions. I'll also try and hang around during the whole day to give advice on models you can try, approaches you can take for each of these challenges, and tips and tricks to get your score up. But if I can't make it, I hope you all have a wonderful time and wishing you the best of luck.